What hidden springs are showcased in this workshop, where they are heated on a conveyor oven to 600 to 900 degrees, held consistently, then cooled gradually, relieving stress and enhancing elasticity. What makes Western Australia stand out in the world of gold and silver is a refinery that has shaped the market for over a century. At its core, the process begins with ore delivered from mines, then melted into liquid form inside powerful furnaces. This molten gold and silver are refined to the highest purity, trusted worldwide. Next, the purified metal is cast into bars and blanks, solid and gleaming. Skilled presses strike them into coins of many designs, each with sharp definition. Finally, bars and coins are packaged and distributed globally, carrying both beauty and value. Operators and machines work together to build a cryogenic tank designed for extreme conditions. The process starts with inspection of incoming steel sheets, then cutting and marking for accuracy. Plates are rolled and welded into shells, strengthened by reinforcing rings. The inner vessel, made from stainless steel, undergoes full radiographic checks. After hydraulic and pneumatic tests, insulation is added, vessels are joined, and vacuuming ensures stability. Painting completes the structure before the final cryogenic product test. Feel the immense power of the 17,000-ton press as it prepares to forge massive steel components. The scale of this operation showcases human ingenuity alongside mechanical might. The workflow emphasizes efficiency and safety at every stage. The press can handle extraordinary sizes that few machines dare to attempt. The process begins with heating a steel billet to a bright red, making it pliable for shaping. Operators position the billet carefully on the press bed. The colossal press descends, compressing the steel into the desired form. The room vibrates as the press releases unmatched force. After forging, pieces are transferred to cooling stations, where they stabilize. Technicians inspect each component for structural integrity. Final adjustments are made using grinding and trimming tools. Step into the world of Rufoni copper cookware and witness centuries of expertise in every movement. Large copper sheets are first cut and cleaned, forming the raw base for each piece. Workers measure each sheet thoroughly before shaping to maintain exact proportions. Craftsmen then mount these sheets on hand-spinning lathes, gradually shaping the rounded body of the pots. Every turn of the lathe is guided by years of experience. The rhythmic sound of hammering reverberates across the workshop, echoing a tradition passed through generations. Pressing and hand hammering refine the shape, ensuring uniform thickness and structural integrity. Sparks sometimes fly as the metal responds to expert hands. After shaping, excess edges are trimmed, and rims are smoothed to perfection. Trimming is performed step by step, each cut ensuring balance and consistency. The workshop is alive with focus and determination, every artisan absorbed in their task. Hands move with confidence, a dance of skill and muscle memory. Hand tinning follows, coating the interior with a protective layer for cooking. Polishing brings a brilliant shine to the copper exterior, highlighting its craftsmanship. The polished copper reflects light like a living flame. Each pot is then inspected for minor deformities, ensuring functionality and beauty. Engraving and decorative touches are sometimes added, giving each piece a unique identity. Small imperfections are corrected immediately, showing pride in every detail. Even small adjustments are treated with care, emphasizing pride in workmanship. Temperature, force, and alignment are constantly monitored during all processes, reflecting a deep understanding of the material. The combination of human touch and specialized machinery allows both efficiency and artistry to coexist. Riveting, sanding, and buffing continue until surfaces are flawless. Buffing and final adjustments are carefully timed to achieve a smooth, even finish. The rhythm of work keeps a steady pulse throughout the workshop. The copper scent and metallic warmth create an atmosphere steeped in history and devotion. Artisans work methodically, yet the creativity in finishing touches reminds one of their artistic spirit. The workshop is a stage where technique and heart intersect, and every step counts. Handles are prepared and carefully riveted onto each pot, combining skill with steady hands. Final quality checks confirm the pot's durability and visual appeal. Packaging is done carefully, preparing the cookware for global shipment. Each product leaves the workshop ready to enrich kitchens worldwide, carrying centuries of knowledge. The process is a living demonstration of craftsmanship, patience, and passion. Each pot represents dedication to excellence and a commitment to preserving tradition. Each stroke seems to echo centuries of accumulated knowledge. Steel and hydraulics merge with human effort as each excavator rises on the line. The process begins with the chassis being fitted with heavy-duty components. Tracks are mounted carefully, providing mobility for construction sites. Each bolt tightened here carries the weight of enormous responsibility. Next, the engine installation phase introduces immense mechanical force, connecting hydraulics and electrical systems. Operators monitor gauges and indicators to ensure proper alignment. The cabin assembly follows, with controls, displays, and operator seats installed. Hydraulic arms are then mounted, tested for range and fluid pressure. Every movement is checked multiple times to guarantee flawless operation. Final inspections verify safety systems and performance. The assembled excavators are driven off the line, ready for testing and deployment. Witnessing the teamwork between humans and machines leaves a lasting impression. The mountain hides a giant heart of steel and concrete, slowly coming to life. Workers break through massive rock formations, shaping the cavern that will house the powerhouse. It's thrilling to witness the enormity of this underground construction. Meanwhile, foundations for the 200-ton transformers are poured, forming the base that will support these enormous machines. Next, the installation of the first steel water control gate begins. Transported in segments, each piece weighing several tons, the gate is maneuvered with extreme care into position. One can't help but marvel at the skill required to position it perfectly under immense water pressure. Once in place, the outflow structure is sealed and tested as water gradually fills the reservoir, confirming the integrity of the construction. Parallel to the underground works, specialized workshops bend and weld steel sheets to form the pump spirals, each 9 meters in diameter and 100 tons in weight. Seeing these spirals being lifted and aligned with millimeter accuracy is awe-inspiring. They are eventually installed in the cavern, paired, fixed with concrete, and connected to turbines. Finally, the cable tunnels and auxiliary structures are completed, ensuring the power generated can flow to the grid safely. Coordination between underground teams and external workshops proves essential. The scale, effort, and precision behind every stage leave a lasting impression. A sense of power fills the air as thick steel plates begin their journey into becoming essential pipelines. The video presents the full sequence of steel pipe production at IPIC. 100% Egyptian steel pipes are produced, each with a wall thickness of 12.7 millimeters. It's remarkable to see local expertise producing world-class steel products. Temperature control is monitored constantly to maintain the steel's ductility during bending. The journey starts with store plates, raw steel sheets carefully prepared for shaping. The raw steel is carefully measured and cut to exact dimensions. The sheer size and weight of these plates hint at the power needed in the next steps. Hydraulic systems apply controlled force to guide the plates through the 3-roll machine with consistent pressure. Next, the plates enter the 3-roll machine, gradually bending them into cylindrical shapes. Observing the metal curve under immense force is both captivating and awe-inspiring. Automated sensors track the bending angle to ensure each cylinder conforms exactly to specifications. Temperature feedback loops maintain optimal heat during bending to prevent micro cracks in the steel. After bending, the post-bending process stabilizes the cylinders, making them ready for the tack welding machine, which temporarily secures edges for initial stability. Welding parameters are adjusted for each pipe section to achieve optimal seam strength. Robotic arms apply consistent tack welds to minimize human error and enhance seam uniformity. The partially welded pipes proceed to pipe processing, where both internal and external welding takes place using specialized machines. It's impressive to see the combination of heat and skill creating strong seams capable of handling extreme pressures. After welding, the pipes undergo visual inspection, checking for any surface irregularities before further processing. Pressure sensors test the welded seams for any leak risks before moving to expansion. Each pipe is then sent through the expander, which ensures diameter uniformity along its full length. The precision of this step highlights the engineering expertise behind every section. Following this, ultra-welding detection uses real-time X-ray machines to verify weld integrity. It is fascinating to watch every millimeter scrutinized instantly for potential flaws. Calibration of the X-ray equipment is performed regularly to guarantee accuracy. Once welding is confirmed, end beveling prepares pipe ends, allowing for precise connections during installation. Even small angle adjustments make a significant difference in final performance. The final inspection ensures that every pipe meets the demanding standards of Petroleum Pipelines Co. (PPC), with a total production of 15 kilometers ready for industrial use. Final dimensional checks confirm both length and roundness before pipes leave the facility. The process reflects both local expertise and adherence to international standards. It is inspiring to see human effort and advanced machinery combine to produce such robust components. Every step, from heating and bending to welding, expanding, and inspecting, is coordinated by skilled teams who ensure the highest quality. With every inspection and adjustment, the steel transforms into a reliable, high-strength pipeline ready to transport fluids under pressure. It's captivating to witness a simple sheet evolve under human skill and machine force. A flat 2 mm zinc-coated steel sheet spins into shape, revealing the skill and force behind every inlet cone. The sheet is first mounted securely onto a spinning lathe. Rotating at high speed, the metal is pressed against a mandrel, gradually taking the desired conical shape. Every pass of the tool leaves the metal gleaming with new form, almost alive under the hands guiding it. Operators carefully adjust the pressure and speed, ensuring the cone wall remains uniform. The zinc coating glimmers as the steel stretches and compresses, revealing subtle reflections of the surrounding light. It's impressive how controlled force can shape something so solid without cracking. The spinning continues, with the base thickened slightly for structural strength. Intermediate measurements confirm the cone meets the specified dimensions, a crucial step to guarantee fitting precision later. As the cone nears completion, finishing touches refine the edge and smooth surface imperfections. Watching the metal respond to every movement of the tool is surprisingly satisfying. Each cone is removed from the lathe and checked for straightness and consistency. The contrast between the flat starting sheet and the finished three-dimensional cone sparks genuine admiration for the craft. Finally, the completed inlet cone is ready for assembly into its larger system. Even in this short process, the harmony between material, machine, and human skill becomes clear. Steel beams line the workshop, ready for high-speed drilling. The line can handle beams up to 12 meters long with precise clamping mechanisms. Each beam is positioned on the automated line, guided precisely to align with the direct drive spindles. The drilling begins, with multiple holes punched at exact intervals. Spindle torque is constantly adjusted to suit varying steel thicknesses. It's fascinating to see such massive metal components receive such accurate perforations. Operators monitor feed rates and spindle rotation, ensuring every hole is drilled consistently. Safety barriers hum softly as the machinery works tirelessly. Watching the system adapt to different beam profiles highlights engineering ingenuity. High-speed sensors track hole depth in real time to maintain uniformity. High-speed drills move with mechanical rhythm, producing holes without burrs or misalignment. Intermediate sensors measure each beam to verify hole positioning. The software calculates optimal drill spacing for each custom beam profile. Even minor adjustments require coordination between human oversight and machine response. Each drill beam represents efficiency and reliability essential for steel construction. Quality checks confirm alignment and diameter consistency. It's impressive how seamlessly automation and human supervision collaborate in this process. Hydraulic force drives the bending of steel sheets in the FMB 20 by 4,000 mm machine. Operators load each workpiece while the CNC system manages automatic flanging. Knuckle roll tilting and rear cylinder positioning maintain consistent angles, producing reliable edges. Low thinning technology ensures material strength is preserved. The coordinated hydraulic action demonstrates the engineering behind high-speed production. Each flange finishes quickly, highlighting durability and dependability. The machine's robust frame supports continuous operation without compromise. Production efficiency combines human oversight with automated precision. Intense heat raises steel blocks to roughly 1,150 degrees Celsius, setting the stage for their transformation into AMTB bars. Every degree is crucial to ensure the steel meets strength and hardness requirements. Once heated, blocks are conveyed along the rolling line and cleaned of scale. Shaping occurs at rolling stands, gradually forming bars with continuous threads. Rolling stands apply controlled force to gradually shape the metal into uniform threads. Rotary shears cut ends to exact lengths, maintaining consistency. Controlled cooling in the TempCore system ensures proper steel hardness and strength. Bars move to cooling beds to solidify, then are trimmed to customer-specified lengths. Bundles are labeled and weighed according to specifications, ready for dispatch. AMTB bars are used in construction, underground works, and rock anchoring, eliminating extra welding or connections. Their design improves efficiency, allowing safe, reusable installations.